Units of heat energy. The SI unit of heat energy is joule. The unit of heat energy in CGS system is calorie. On heating a substance, its temperature increases. The quantity of heat required to raise the temperature of a body of mass m is given by Q is equal to mst joule. M is equal to mass of the substance in kg. S is equal to specific heat of the substance in joule per kilogram per Kelvin. T is equal to change in temperature in Kelvin. Calorie. It is the amount of heat required to heat 1 gram of water through 1 degree Celsius. Kilocalorie. It is the amount of heat required to heat 1 kilogram of water through 1 degree Celsius. The relation between calorie, kilocalorie, and joule is 1 kilocalorie is equal to 1000 calories. 1 kilocalorie is equal to 4200 joules. 1 calorie is equal to 4.2 joules. Change of state. Matter can exist in 3 states of matter, namely solid, liquid, and gas, under different conditions of temperature and pressure. The process of change from one state to another state at constant temperature is called change of state. This change of state takes place either by heating or cooling. Melting. It is a process of converting a solid into liquid by heating. This takes place only at a constant temperature, which is known as melting point. Melting point. It is a constant temperature at which a solid is converted fully into liquid on heating. Melting point of pure ice is 0 degrees Celsius. Boiling. Boiling is a process of converting a liquid into gas by heating, which is also known as vaporization. Vaporization takes place at a particular temperature known as boiling point. Boiling point. It is constant temperature at which a liquid gets converted fully into a gas. Boiling point of pure water is 100 degrees Celsius. Condensation. It is a process of converting a gas into a liquid by cooling. Freezing. It is the process of converting a liquid into solid by cooling. Sublimation. The process of converting a solid directly into gas on heating is known as sublimation. Iodine, camphor, etc. The state changes directly from solid to gas without going through the liquid state on heating. Evaporation. The change of state of a liquid to a gas, which takes place at all temperatures, is known as evaporation. linear expansion and coefficient of linear expansion. When rods of same material of different lengths are heated through the same increase in temperature, it is found that the longer rods expand more than the shorter rods. Increase in length is proportional to its original length. Increase in length is directly proportional to the increase in temperature. Increase in length also depends upon the material of the body. Thus, coefficient of linear expansion is the increase in length per unit original length per degree increase in temperature. It is measured in degrees Celsius power of -1. Heat engines. Heat engine is one which converts heat energy into mechanical energy. Mainly, there are two types of heat engines. External combustion engine, example, steam engine. Internal combustion engine, example, auto or petrol engine and diesel engine. Petrol or auto engine. This type of engine is used in light cars, scooters, aeroplanes, etc. The working substance in this engine is a mixture of petrol and air prepared outside the cylinder in a carburetor. Construction. The cylinder of the engine is provided with two valves, O and I, called inlet and outlet or exhaust valves respectively. A spark plug P is inserted into the cylinder which produces a spark at the right moment to cause combustion. Charging or suction stroke. During this stroke, the piston moves outwards, the inlet valve I opens, and mixture of petrol vapor and air prepared in carburetor is sucked in at atmospheric pressure. Compression stroke. During this stroke, the piston moves inward and compresses the mixture to about 1/6 of the original volume. Temperature of mixture rises to about 900 Kelvin due to compression. Valves O and I are closed. Working stroke. Just before the completion of compression stroke, the spark plug P produces instant spark. Combustion is produced in fuel due to spark and temperature rises to about 2300 Kelvin while pressure rises to about 15 atmospheres. The piston is pushed outwards due to huge pressure. Due to pushing of the piston out, useful mechanical work is done at the cost of heat energy. During this stroke, valves O and I remain closed. Exhaust stroke. Just before the piston reaches the end of the working stroke, the exhaust or outlet valve O opens. The piston starts moving inwards and the burnt gas are forced out. However, valve I remains closed during the stroke. The cycle is repeated time and again. Cooling. Due to ignition of fuel, a large amount of heat is produced. If no cooling arrangement is done, valves, piston will expand and proper working will be affected. To keep the engine cool, a jacket of water surrounds the cylinder. The water is kept circulating around the engine. However, in two-wheelers, the cylinder is subjected to air cooling. Differences between evaporation and boiling. Boiling, evaporation. Boiling takes place at a fixed temperature. Evaporation takes place at all temperatures. Boiling takes place throughout the liquid. Evaporation takes place at the surface of the liquid only. Boiling is a noisy process. Evaporation is a silent process. Boiling is a rapid process. Evaporation is a slow process. Heating effect is produced in boiling. Cooling effect is produced in evaporation. Heat. Heat is a form of energy. Heat travels from a body which is at a higher temperature to a body at a lower temperature when the two bodies are in contact with each other till both bodies attain the same temperature. Kinetic theory of matter. A molecule is the smallest part of a substance, which can exist in a free state and retain all the properties of the parent substance. Thus, the kinetic theory of matter is based upon the following fundamental principles. All matter is composed of molecules. The molecules are in a state of continuous rapid motion. The molecules exert some force of attraction upon one another, the force decreasing rapidly as the molecules move further apart. Kinetic theory and three states of matter. In terms of the kinetic theory, the difference between solids, liquids, and gases can be briefly stated as follows. Solid state. In a solid, strong cohesive forces rigidly bind the molecules. Each molecule oscillates about a fixed point without leaving its position with reference to the other molecules. Liquid state. In a liquid, the molecules are free to move about, though they are still held together in a body of fixed volume by weak cohesive forces. The velocities of the molecules are distributed about a certain average value, some having velocities greater and others less than this average. Gaseous state. In gas, the molecules are far apart and have negligible force of cohesion for each other. They are quite free to move in all directions and thus completely fill the vessel in which the gas is contained. Thus, a gas has no shape or volume of its own. It is this complete freedom of movement of the molecules which gives a gas its striking property of unlimited expansibility. Latent heat. The heat used by the substance to change its state without any change in temperature is known as latent heat or hidden heat. Latent heat of fusion. The latent heat of fusion is the quantity of heat required to convert unit mass of the substance at its melting point completely into liquid at the same temperature. Latent heat of vaporization. Latent heat of vaporization is the quantity of heat required to convert unit mass of a liquid at its boiling point completely into its vapor at the same temperature. Humidity. Amount of water vapor present in the atmosphere is known as humidity. Relative humidity. Relative humidity is the ratio of quantity of water vapor actually present in air at a certain temperature to the maximum quantity of water vapor that the air can hold at the same temperature. Effects of humidity on weather. If the humidity is low, the air will be dry, hence the chances of rainfall will be low. If the humidity is high, the air will be damp, thus rainfall will be high as water vapor condenses to form rain. Principles of mixtures. According to the principle of mixtures, heat lost by the hot body is equal to heat gained by the cold body, provided no heat is lost to the surroundings. Calorimeter. Calorimeter is an apparatus used to measure the quantity of heat, that is, heat lost or heat gained by any substance, which was devised by Renault. It consists of a small cylindrical, well-polished copper vessel provided with a stirrer of the same material, which is used to maintain uniformity in the temperature. The calorimeter is brightly polished to reduce the heat loss due to radiation. It is placed in a wooden box stuffed with wool or cotton to prevent heat loss due to conduction and is closed by a wooden lid. There is a hole in the lid through which a thermometer can be inserted and clamped. Specific heat and heat capacity. Different substances require different amounts of heat for the same raise in temperature. The amount of heat required to raise the temperature of the substance depends on the nature of the substance, which is known as the specific heat of the substance. Some substances may require lesser amount of heat to raise the temperature of 1 gram of the substance through 1 degree Celsius. Some may require more amount of heat for the same rise in temperature of 1 gram of the substance. Oil gets heated up more quickly than water. Specific heat capacity. Specific heat capacity is defined as the quantity of heat required to raise the temperature of unit mass of the substance through 1 Kelvin. The SI unit of specific heat capacity is Joule kilogram power minus 1 Kelvin power minus 1. Heat. Thermal capacity. Heat capacity is the quantity of heat required to raise the temperature of whole mass of the substance through 1 Kelvin. The SI unit of thermal capacity, Joule Kelvin power minus 1. Expansion of solids. Solids possess definite volume and shape. When heated, it expands in all directions. This results in an increase in length, area, and volume when heated. Gravesend demonstrated experimentally that solids expand on heating. He took a metallic ring and a metallic ball. The diameter of the ball is slightly less than that of the ring, and the ball can easily pass through the ring at room temperature. The ball is heated on a burner and now passed through the ring. It was observed that the ball did not pass through the ring. Thus, it is concluded that solids expand on heating, and so the ball, which expanded to such an extent that its diameter had become more than that of the ring. Diesel engine. This type of engine is used in heavy cars, trucks, buses, tanks, and other heavy vehicles. Unlike the petrol engine, the fuel, that is diesel, is sprayed in the cylinder moments before it is ignited. There is no spark plug in it, and fuel is burnt due to heat produced due to excessive compression. Construction. It consists of a very stout, tough cylinder and has got two valves, one inlet valve I and another exhaust or outlet valve O. An arrangement is made in it to spray fuel, that is diesel, just before the working stroke. Working. It is a 4-stroke engine. The strokes are charging or suction stroke. Dry air is sucked in this stroke through inlet valve. Outlet valve O keeps closed during this stroke. Piston moves back to suck air. Compression stroke. During this stroke, the piston moves inwards and compresses the mixture to about 1/15th of the initial volume. The temperature rises to about 2000 Kelvin due to huge compression. Working stroke. Just on completion of compression stroke, the sprayer sprays a proper amount of fuel, that is, diesel. Due to huge temperature of air inside, the diesel catches fire and huge pressure is produced inside. The temperature is also raised considerably. Piston is pushed outward with huge pressure. A good amount of heat is converted into mechanical energy. Exhaust stroke. The outlet or exhaust valve O is opened and burnt gases are forced out in atmosphere due to inwards motion of the piston. Cooling. Since huge amount of heat is produced, the engine will stop working after some time due to expansion of valves and cylinder if no cooling arrangement is done. The engine is cooled from outside by circulating water in water jacket around the engine. Some evidences of random motion of gas molecules. Diffusion. This is a process by which the molecules of one kind penetrate and intermix with the molecules of another kind is called diffusion. Phenomenon of evaporation. The process of evaporation thus consists in the escape of the fast-moving molecules. Brownian movement. When very small bits of a solid suspended in a liquid or gas, the particles are seen to be in a state of agitation, moving irregularly through short distances, as if they are struck from various directions by bodies of different momenta. Tendency of a gas expansion. The molecules of a gas tend to fly away from each other, thus imparting to it the property of expansibility.